Hello, everyone. Wow, that was really loud. Okay. Welcome back. We hope you had a wonderful lunch. We're excited to welcome you to session 3, where we'll be talking about information dynamics in the media. So again, you've heard a lot from traditional clinical data sources, so we're excited to, again, start to explore some of the non-traditional elements of media. So our first presenter will be my fellow moderator, Rebekah Baglini. She's an assistant professor at Aarhus University. She'll be talking about detecting an information signature of catastrophes and legacy news media. Over to you.
Thanks, Matt. Everyone hear me? Great. Yeah, so I'm here representing the Center for Humanities Computing at Aarhus University, which is a research group that has been working with the HOPE project that you've heard a lot about. We've been working with them since day one, March 13th, 2020 or thereabouts. And what we've been doing is primarily focusing on the data collection for media sources, and that includes traditional news media and also social media. So what I'll be talking about today is just a tiny fraction of what my group has worked on this past year. We have a lot of data that we're excited to share with you this weekend. But today I'll be focusing on one aspect of our research, which has been Danish news media throughout the pandemic era. So this is joint work with several people from Center for Humanities Computing. 2 of them are here for the whole weekend, Kenneth and Yen, and we're really looking forward to seeing what comes out of this Datathon. So there's a quote that one of my colleagues likes to start talks about this work with, which comes from Douglas Adams, The Hitchhiker's Guide to the Galaxy. Nothing travels faster than the speed of light, with the possible exception of bad news, which obeys its own special laws. And what we're kind of trying to do with this work is to look into what those special laws are and how they operate. So how can we start to quantify and measure how it is that news media responds to a catastrophic event like COVID-19, which, as it turns out, is kind of a perfect natural experiment for looking at this? If you're familiar with trend detection in the media, it's often done by looking at variation in just one or a few individual words and their co-occurrence patterns, or maybe topics consisting of sets of words. But this can be really useful, but of course it misses some things. It misses a lot because it only shows you exactly what you're looking for. So you have to come up with the queries or the terms or the topics that you're interested in. And our work here takes a different approach to trend detection in newspapers by extracting information signals from latent variables generated over the whole text. So just to get an intuitive feel of what we're doing, you can think about taking a pile of newspapers like this for every single day of the pandemic, and then using various statistical techniques to sort of extract patterns that then we can look at longitudinally. How do they change over time? And specifically, how do they change in response to external events in the world? So variation in newspapers' word usage, it's already well known that this is sensitive to the dynamics of external events and can even help detect event-driven shifts. So this was sort of our starting point, the background literature on this. We then use latent variable modeling and information theory to measure just how a catastrophic event disrupts the ordinary information dynamics of news media. So this is interesting in and of itself, I think, and that's what I'll be presenting on today. But you can really imagine a lot of downstream applications, like how is it that these signals that we identify, how do they covary with other, relevant time series data, like the other data we'll be looking at this weekend. Our data set comes from Infomedia, and they supplied us with print versions of 8 different newspapers from throughout the pandemic period, from December 2019 until the present. The list of these papers is here. And of course, we had to do quite a bit of pre-processing. So all of our research focuses on front pages from these newspapers, on the assumption that, of course, the front page is where the newsiest news exists, and so we should see the strongest signals there. The report that I'm going to talk about today, it only goes until June 2020, but our data goes up until the present. We pre-process by removing ads, metadata, stop words. We do some standard like NLP pre-processing, like TF, IDF weighting. And then we basically want to convert these texts into a bag of words vectorized representation. So bag of words just means that we're not paying attention at all to the order of the words in a front page or their position. So we're treating it like it's a bag shaken up of words. So really this means that we're representing all of these articles as like a co-occurrence matrix of terms. That's all a front page consists of here. Then we use a generative statistical model called latent dirichlet allocation to generate a dense low-rank representation of each topic thematically. So basically, how is it made up of different topics? And then you're able to sort of compare each front page with another front page in terms of the topic distribution. So that's the way that this data is represented, and I'll talk more about this in a couple hours in the lead up to the Datathon. So once we've temporally sorted our data, we apply a windowed relative entropy measure to the thematic text representations to generate two primary signals, novelty and resonance. And I'm not going to get into the details, but basically novelty is measuring the reliable content difference from the past, and resonance is measuring the degree to which future information conforms to that novelty. And what we're interested in is the variation in the novelty-resonance association over time, because this can predict significant change points in historical data. So to see what happens during the kind of inflection points of the pandemic, we need to start by getting some sort of a baseline. Like, what does news look like in the Danish media context outside of the crisis period? So right here, we're focusing on the period from December 1st to February 27th. That's the day when the first COVID case was identified within Denmark. And we're looking here at 4 different newspapers. And what we see is, so what this graph shows is just this beta coefficient is the fit of resonance on novelty. What we see is a medium to strong association between those. So this is basically what the association looks like in normal times. So to model trends over time, we apply this nonlinear adaptive filter to the signal, the daily signal, of both novelty and resonance, just to filter out some of the noise. So in these graphs, in the top graphs, the darker the line, basically the more filtered it is. So the more smoothed out it is. But this is all showing the same thing, either novelty or resonance. So what we see is there's this normal period up until about midway through the graph where the virus really hits Denmark. A short time later, the lockdown happens, and then a couple months later, we begin to reopen. So we've just kind of put these little labels there to help you visualize this. What we see is this really interesting and unusual pattern where at around the point of the lockdown, novelty really plummets and resonance goes up. So in a sense, they're decoupled, which is contrary to the normal way that novelty and resonance are fit in the news cycle. They're usually pretty strongly associated. During the crisis, they get decoupled. So based on how I explained novelty and resonance, you can sort of start to have an intuition about why this would be. So what happens with the onset of the crisis is that basically the news is taken over by one topic, COVID. So suddenly the news isn't as novel as it usually is because the same words, the same expressions and collocations are being repeated day after day. And the longer that goes on, the more resonance is going to increase because resonance is measuring the degree to which the novelty rate persists over time. So we think that this decoupling effect is something that's very sort of significant in indicating the presence of a sort of informational crisis. So this was Politiken. I'm just going to very quickly show you that we see the same pattern more or less in all of the newspapers that we look at, although it is more pronounced in what we would call like omnibus papers rather than tabloid papers. So here's Ekstrabladet. But we see the same effect across all of our news data. So the main takeaway that we sort of identify is this principle of news information decoupling, that a catastrophe initially disrupts the ordinary information dynamics by decoupling novelty and resonance. And then over time, things will sort of go back to the normal state. Now, an interesting finding that we report on in one of our papers from this project is that what kind of crisis is it that we can detect using this news information decoupling principle? Is it always a natural or a sort of health-related crisis like COVID-19 or a pandemic? Or could it be something more related to a social or political crisis? And I think we have some initial evidence that it can really be any sort of a crisis or an upheaval that's reflected in the news this way, provided that it's large enough in scope and that it affects the news in a particular sort of way. And some evidence from this comes from data that's visualized here. So here what we've done is we have the fit of resonance on novelty plotted over time. And we've zoomed in at the relevant sort of event periods to the sort of slope. So we can see how the slopes differ at these different points of the pandemic between two different papers. We've got Politiken versus Berlingske. And for people familiar with Danish news here, you know that the sort of political orientation, the alignment of these papers is somewhat different. So these two papers don't really differ so much in the novelty resonance association at the primary pandemic periods that we've identified. But if you look at the period following reopening, and also this trend continued for quite a while, you'll see that while Politiken is showing a very sort of normal novelty resonance association, Berlingske is still showing a sort of crisis-like profile. You see this from the very low value for novelty on resonance. So why is this? Well, if you look closely at the actual content of the news, Politiken is a paper that's much more aligned with the Social Democrats, with Mette Frederiksen's party, and the party that's taken a really lead role in implementing coronavirus policy. So whereas Berlingske has taken a more somewhat crisis-focused view of the economic and social impacts of the lockdown policies, a somewhat more critical take. And so naturally, in this paper, the reopening phase doesn't necessarily correspond to a totally normal news cycle. The crisis is still persisting here, and we actually see this reflected in our data. So I tried to keep this to 10 minutes, so I'm going to have to wrap it up. But the main takeaways here are that news information decoupling behavior is a reliable signal of catastrophe in the legacy news media. And so in other words, no news is bad news. When you see no news persisting over time, that's a sign that things have gone wrong in society. So I think I want to thank all of our sort of collaborators here, Infomedia, HOPE, Center for Humanities Computing, Data Lab as well. And I think one more thing that I'll mention is that I think this is an interesting sort of result, this focusing on the information dynamics on its own. But I'm sure you can all see that the value of this data will also come out in how it is sort of correlated with other time series data and looking at how it co-varies. So I'm really looking forward to what we can learn this weekend. Thank you very much.
Great, and with that, we'll open it up to the floor for questions.
Yes?
Thank you. That was just really, really interesting. I was wondering if it was a smart choice to go all the way to February 27 with your baseline validation set, because there was a lot of international communication about both Wuhan, but also Italy and the Middle East during those months, and that upset some, not others. So that's one thing. The other one, are you aware that actually we can read the historical newspapers online in Denmark all the way back to 17-something?
Yes.
And you might be able to do something with the 1918 pandemic, for example.
Yeah, that would be really interesting. We have an agreement. So in order to get the raw raw data. We actually have a special agreement with Infomedia, and the earliest we've been able to go back is December 2019. But I think it would be a lot of the work that this work takes inspiration from is actually work by historians, like digital historians, who have used similar techniques for looking at historical newspapers. Going back to your first question about February 27th, that's a great question. So actually, we didn't arbitrarily choose February 27th to, well, in some ways we did, but that choice was actually bolstered by the information signal and using another statistical technique called change point detection. So one thing that's really interesting that we observed is that the change point, the point when novelty and resonance begin to decouple, it doesn't actually start as early as you might expect when the news is coming out of Italy and Iran that this pandemic is taking off and it's spreading. It actually really starts to take off in Denmark right before the lockdown and right after the first cases were identified here. So in some ways, this is telling us that the sort of catastrophe effects in Danish news media is very localized to Denmark. We felt like we were, I think those of us who were in Denmark, this resonates, we really felt like we were in kind of a protected bubble. I remember we were at work on, March 9th, sitting around the lunch table having a normal day, and that night we found out the whole country is going to be locked down for the foreseeable future. So it hit us like a ton of bricks, and you kind of see that in our data. I think there was another, yeah.
Yeah, thank you for this very interesting talk. I'm Johannes, and I'm a medical doctor and PhD student here. I had a bit of trouble understanding the resonancy parameter. Novelty was a bit easier. Do you have an example of a situation, not an example, but could you imagine an example where novelty would drop without resonancy increasing? Like, what would that mean?
Yeah, so I mean, that could happen on the sort of local level at any point. I think that happens. So resonance is really detecting the persistence of a fluctuation in novelty. So if novelty were to drop off for just a day or two, so remember that everything we're doing is measuring the relative entropy in a windowed way. And I think for most of these results, except for the last slide, we're looking at a window of 7 days. So basically, the resonance is only going to go up if the novelty drops for a significant enough amount of time that it sort of falls outside of the norm. Yeah.
If I understand this correctly, so resonance really measures sort of the level of noise in the previous term. What was it? The novelty, right? Mm-hmm. That's what it is. So it doesn't have anything intrinsic to do with whether the novelty is low or high, but rather whether there's big fluctuations at any given time, right?
Exactly.
So you could equally well imagine novelty being continuously very, very high, but as long as it's stable, you would have low resonance, right? Maybe
that's
that answers the question from before. So in that sense, you could also say that if novelty is very high, you don't have news, right? Because that's sort of like what we have this term in Danish called a gurketid. They find something new to write about every single day because nothing is really happening. Yeah. That would be very high novelty, right?
Yeah. Of course, there are sort of more local cases of novelty, dropping off. So let's say that there's a massive flood or something. So let's think about like Germany a month or two ago. Probably all of the German front page news sources were dominated by coverage of the flood for maybe 2 or 3 days. But after that, it sort of becomes, it's still being reported on, but it's not every single article on the front page. So in that case, resonance would not be affected as much because the persistence of the drop-off in novelty is more sort of time limited.
Have you ever looked into sort of local sort of geographic patterns in novelty? You could imagine, as you say, something happening at a local scale. That then really spreads out like a fissure wave or something like that?
That's a really good question, and that's something I think we could do if we looked into more local news sources, which we don't really have here.
Yeah. Okay. Cool.